Good morning, everyone. I'm Yi Mei. Thank you for coming to this session. So today I'm going to introduce you to an approach or method that I came up with my colleagues on site prioritization for conservation planning, which we hope can be used on any types of ecosystems. But what we did here is we tested it on seagrass meadows in Southeast Asia, and that's what I'm really talking about today. So I'm just going to skip past the whole why seagrasses are important, because I'm sure you all know that, and go straight to the problem. So as we know, seagrasses are really important, but they're being lost at a drastic rate, and this loss is even harder to quantify in areas where there's a general lack of data, such as in Southeast Asia, which has more than half the number of seagrass species, and large expanses of seagrass meadows, but yet most of these are still not studied yet. Seagrass loss in Southeast Asia is also further exacerbated because of poor governance, outweighing of economic needs over conservation priorities, uncontrolled rapid development, and also a general lack of environmental awareness. So the cost of conservation can be very high, both such as the creation of MPAs or seagrass restoration, both to start and to maintain. And so in order to ensure effective resource allocation, we need to come up with a systematic approach for prioritization. However, current decision support tools generally require some level of expertise of or access to software such as GIS or other modeling software, or detailed information about the area or ecosystem of interest. And this is not always available or accessible to resource managers. So, to counter these issues, the canvassing for expert opinions has gained traction over the past few years, and this can be through workshops or surveys to assess conservation priorities. These include vulnerability assessments and scoring of ecosystem services. So I have problems pronouncing vulnerability, and to prevent further embarrassment, I'm just going to call it VU and ES from now on. Okay, VU and ES assess two different things, but ultimately they can be used to make informed decisions on which sites are the most impacted or which sites are the most valuable, and in order to direct conservation efforts. So while these two methods have been used globally for planning and management, the combination of the two indices has not been explored, and this is where we come in. So what did we do? We chose 6 sites across 5 countries from a previous ES paper from Nakaoka et al. In 2014. And additionally, we chose 1 site that spans Cambodia and Vietnam from the UNEP GF South China Sea project. So all these sites had basic information, which allowed for to facilitate the assessment and to ensure equitability in testing of methods. The VU and ES assessments were carried out by myself and my colleagues, the ones who worked on the paper together. So it wasn't. It was more of a testing of a method and not testing and developing of the method, and so it wasn't sent out to volunteers to test out for throughout the world. Okay. First up, the scoring of ecosystem goods and benefits. We chose 13 ecosystem goods and benefits, and only the final goods and benefits were scored. So we scored them based on their contribution, the contribution of the meadow, and the significance of the contribution, and this was based on factors such as meadow size, species presence, species richness, number of educational programs associated with the meadow, or the known presence of charismatic fauna associated with the meadow. The condition of the meadow was also scored. This was based on the direction of change in Nakaoka et al., and this was to give an indication of whether the ES was degrading, improving, or remaining stable. There was also a significance score from 0 to 4, and while this wasn't used in the equation for the ES score, it was helpful to indicate the confidence level behind the scoring, and in the future it can also be useful to direct conservation efforts. So for example, if the confidence level is low, you know that the initial conservation efforts should include things like surveying surveying and monitoring to establish a baseline condition so that you have a baseline condition to assess any conservation success against. The VU analysis. So it was based on the method developed by Halpern et al. In 2007, which has since been applied successfully for seagrass meadows. The only difference is that we had an additional level for resistance. Resistance is futile. And this was in cases such as land reclamation, because where there is land reclamation, it's a complete loss of habitat, and recolonization is unlikely or probably impossible, hence resistance is futile. We chose 16 threats, which can be classified into 5 categories, and then for each site they were scored, excuse me, assessed for each of these threats, and then the totals VU score is just the sum of all the threats. Yes. And finally, the combined analysis, which was a ranking exercise. So we ranked the ES scores from the lowest, rank 1, to the highest, rank 7. And the same for the VU scores. The least vulnerable was rank 1, and the most vulnerable is rank 7. And the combined score was just the multiplication of the two. They were then ranked in ascending numerical order, i.e. the highest score indicates the sites with the most urgent need for management and conservation action. So the rationale behind this ranking was that conservation priority should be given to seagrass meadows that have the highest ecosystem value, but are also the most vulnerable in terms of the magnitude of threats faced. So since this is where the largest losses in terms of both seagrass cover and ES derived are expected to occur. Results. The highest ecosystem service value was in Thailand, and the lowest was in Indonesian West, followed by the Cambodian, Vietnam, and Malaysia. So for Malaysia and Indonesia West, we think that this was likely driven by the highly negative direction of change, meaning that the ecosystem service values are degrading. And for Cambodia, Vietnam, and Indonesia West, it's likely due to the fact that they're not very well studied, especially for Cambodia, Vietnam, where a lot of basic information is only just coming to light. For Malaysia, what I said about the negative direction of change, if you can remember from Dr. Rahman's talk yesterday, the meadow at Sungai Pulai Estuary is traditionally high in ES for the coastal communities, but is currently being affected by various developments in the site, hence the degrading ES score. 6 out of the 7 meadows scored are undergoing some degree of degradation, and only Singapore was showing improvement. This is likely due to the fact that the Singapore site is Chek Jawa. Some of you will visit on Thursday, and Chek Jawa was designated as a wetland area in 2002, coming under the management of the National Parks Board in Singapore. So several improvements have been made to Chek Jawa to make it more accessible to the public for nature education, outreach, research. And it also comes from regular monitoring data, which has shown an increase in above ground biomass from 2007 to 2013. VU. So going back to this, if you can remember, these are the 3 sites with the lowest ES. They were also the 3 sites with the highest VU, IDW, CV, and MOI. The lowest VU was at Thailand, which again is the same, it had the highest ES. Most of the threats scored, that were scored the most highly were those that caused the degradation in water quality, so such as untreated sewage, nutrient enrichment, runoff, sedimentation. And finally, the combined analysis. So the 3 sites that should be prioritized were IDE, Indonesia East, Malaysia, and Philippines. And the lowest were Indonesia West and Thailand. It's interesting to note that for Indonesia West and Thailand is exactly the opposite. So Indonesia West had the lowest ecosystem service rank and the highest vulnerability, and Thailand had the highest ecosystem rank and the lowest vulnerability. So what do these results mean? To recap, the rationale behind our method. Ideally, it should prioritize sites with a combination of high ES values and moderate to high VU, as these sites are likely to offer value to coastal communities and to restrict any further degradation to these seagrass meadows. Going through this assessment, we were able to pinpoint the areas that needed working on. For example, in Indonesia West and Philippines, which are quite high, which were high on the ES rank, we identified the drivers of change at each site, which allows us to make management decisions and actions to halt and reverse degradation linked to these anthropogenic threats to ensure that these meadows either maintain or return to a healthy state. But it doesn't mean that we ignore the sites that are lowest on the rank. So for example, Thailand, which is currently ranked the highest, this is probably due to the fact that it's in a marine national park, so the ES values are quite high. It's not undergoing as many anthropogenic threats, but still we need to halt any further anthropogenic threats that might be introduced in the future. And also for Indonesia West, which is the lowest currently, we need to stop further degradation at the site. So yes, we were able to identify the industries and the activities that need to be targeted and the respective government agencies and stakeholder groups that have the ability to implement changes. One of the future research areas we identified is cultural ES because it's often intangible and lacks a common and distinct definition, which makes it difficult to incorporate into any assessment frameworks. But we can counter this through a variety of methods, such as the use of social media or local level stakeholder engagement, as well as questionnaires that have fixed indicative questions that you can use to compare across sites and regions. So the perks of our method. It's an evidence-based decision support tool for small-scale regional assessment. It's easy to use because it doesn't require such detailed information or access to expensive high-tech software, and so anybody can use it. And also because it focuses on two different aspects, it means that there's multiple lines of evidence included in the decision-making process. Yes, it's clear, transparent, leaves an auditable trail, and is replicable across other ecosystems. Going forward, we need to include things like spatial elements, such as meadow connectivity, because these things relate to persistence, and that wasn't included. We also need to look into scoring of intermediate goods and benefits. And we are confident that this method can address the concerns of various stakeholders, and now it needs to be tested. So we are keen to test this method on any of your seagrass meadows. So we'll be grateful if you're willing to participate and when we contact you for collaboration. Thanks. Or you can read the paper. It's in Botanica Marina.
Thank you, Yi Mei. We have about a minute and a half. If we have anyone has any questions they'd like to ask. Das. I'm not going to be able to reach that far.
See, I understand your rationale for combining both ES and VU, but I don't understand your rationale for giving similar weightage for ES and VU. You change weightage a little bit, then your priority action will also be changed, or prioritization of those sites will change. For example, probably it was IDW, Indonesia West and Thailand. You see, VU was 1771, but when you rank them, it comes same, and then when you give combine both the scores, your ranking will be almost same. So if you change weightage, see, situation-wise, your weightage can be changed. Depending on ecosystem services and VU. If weightage for each you change, then your priority of sites also will be changed. Try that way to see if you are getting better results, or it is just another attempt to do that.
Yeah, thanks for the suggestion. We will take that on board. But I guess for this one, what we wanted to do is it's kind of like a more bang for your buck, right? So like if your sites are too vulnerable, you need to put in a lot more effort and money to move it past that stage. So we wanted to target sites that are high in ES value, but also not so degraded that it takes too much effort, if you get what I mean. Yeah, but yeah, we'll try that. Thanks.
Okay, thank you very much, Yi Mei. It was quite interesting.